You know, in the world of AI, the race has always felt like it's about getting bigger and bigger. But what if the next big leap isn't about getting larger, but about getting smarter? Today, we're diving into Baidu's brand new model, ERNIE 4.5, and it represents a really fascinating and different way of thinking about powerful AI. And this right here, this is the central question that's kind of haunting the entire AI industry right now. We all want these incredible, powerful models that can reason like nothing else. But the cost, and I mean both the financial cost and the sheer computing power, is just skyrocketing. So this tension, this tug of war between power and efficiency, is exactly what a model like ERNIE is built to solve. So, okay, at first glance, ERNIE 4.5 looks like just another giant in the field, right? It's got 21 billion total parameters. That is a huge number, and it seems to be right in line with this trend of just building these massive, massive models. But hold on a second. That's not the whole story. Because here's the twist. While the model has 21 billion parameters under the hood, it only ever uses about 3 billion of them at any given time to actually process a request. So wait, how is that even possible? And maybe more importantly, what does that actually mean for its performance? This brings us to the model itself, ERNIE-4.5-21B-A3B-Thinking. Yeah, it's quite a name, I know, but it kind of tells you the whole story. Baidu's researchers believe that this specific balance, that 3 billion active parameters, might just be the practical sweet spot for getting top-tier reasoning without the crazy deployment costs. To really appreciate what ERNIE is doing here, we first have to understand the problem it's trying to fix. For a while now, the AI industry has been in this arms race, where the default thinking is just bigger is always better. But that way of thinking creates some very real and very significant challenges. So here's the deal with most traditional dense models. They activate all of their parameters for every single task you give them. As you can imagine, this leads to incredibly high compute costs, it slows down response times, and it makes them extremely difficult for most companies to actually use in the real world. I mean, these models are super powerful, but they're almost walled off by their own massive resource needs. So how does ERNIE get around this whole problem? Well, the secret sauce is in this really clever architecture called a mixture of experts, or MoE for short. Instead of one giant brain trying to do everything at once, think of it more like a highly efficient team of specialists. Let's break down how that team works. So here's the core idea. In an MoE model, you don't have one big network. You have a collection of smaller, specialized expert networks. When a new task comes in, a router network acts like a manager and intelligently decides which specific experts are the best for that job, and it wakes only them up. Let's use an office analogy to make this super clear. A question comes in, that's the task. The router is like a brilliant manager who instantly knows who on the team to give it to. Is it a math problem? Send it to the math expert. Is it a language question? Send it to the grammar guru. Only that one specialist gets to work, which saves a massive amount of energy, and you still get a high-quality answer back. Now, of course, making this team of specialists work smoothly takes some clever management. These technical terms you see here, they're basically the training rules for that router, for that manager. They make sure the manager doesn't get lazy and just send every single task to the same 1 or 2 star players. This keeps the whole team active, specialized, and balanced. But look, ERNIE's story isn't just about its efficient design. That clever architecture is really the foundation for some seriously impressive capabilities that make it a real contender. So let's talk about its superpowers. Okay, so here are the highlights. It can process a massive amount of text at once. It can connect to and use external tools, which is super useful. It's been specifically trained for advanced reasoning. And this one's a big deal. It's open for commercial use, which is definitely not always the case with these top-tier models. Let's just focus on this number for a second, a 128,000 token context length. What does that actually mean for you? It means the model can basically read and remember an entire research paper, or a long legal document, or even a complex code base, all in one go. For any kind of deep, multi-step thinking, that is an absolute game changer. And achieving this huge memory wasn't an accident or an afterthought. It was built into its core design right from day one. The team used some really advanced optimizations, like the ones you see here, to make sure the model could handle all that information without just slowing to a crawl. The really crucial point here is that ERNIE was specifically groomed to be a thinker. After its initial training, it was put through this rigorous fine-tuning process that focused on logic, math, and coding. You can think of it like a multi-stage recipe to sharpen its ability to tackle those really complex, reasoning-heavy tasks. So when you put all of this together, where does it leave ERNIE in this very crowded AI landscape? Well, it's pretty clear it's not trying to be the biggest model on the block. Instead, it's carving out its own unique and really powerful position by being smarter, not just bigger. When you put ERNIE side by side with its competitors, its unique approach just pops right out. Many rivals are using those dense architectures with huge active parameter counts, but ERNIE is lean and efficient. Its massive context window was trained from the ground up, not just tacked on later. And crucially, its open license makes it so much more accessible for businesses to actually build with. This quote from Baidu's own research summary is honestly the perfect thesis for this entire project. It's a bold claim that directly challenges the dominant bigger is better philosophy in AI development today, and ERNIE 4.5, well, it's their proof. It's showing that performance and efficiency don't have to be a trade-off. And all of this leaves us with a pretty fascinating final thought to chew on. For years, the AI race has been all about scale. But as models like ERNIE are starting to prove, maybe the next great innovations won't come from building ever bigger digital brains, but from designing much more efficient ones. Is this where the future of AI is actually heading? It's definitely something to think about.